Let's kick off with today's webinar. Today's webinar is on hidden cost of cloud, where we are going to talk about 5 different examples or 5 different types of cost, which often goes overlooked during the planning by the engineering team whenever we are planning our cloud cost or whenever we are reviewing our bill. These kind of costs are hard to spot sometimes and often goes overlooked in the larger scheme of things. So we are going to pick them up, those examples, and we are going to talk about why they happen, how you can spot them quickly, and what you can also do to basically reduce those minimize those kind of cost, right? So first of all, I would like to thank hugely to the entire team of Clofio and CloudMouth for organizing today's workshop. Let me start with a quick round of introduction. Let me quickly check if the slide is moving. Yeah, the slide is moving. So let me start with a quick round of introduction. Myself, Atanu Roy, I am the co-founder and CEO of Clofio. I will be walking you through today's content. I also have with me Ambar, who is the co-founder and CEO of Clofio, who will be the host and moderator for today's session. This is, as Amber mentioned in the beginning, this is our second webinar in the series. In the first webinar, we actually talked about cloud cost accidents, a few very common examples of how people miss, smaller nuances within their cloud cost, and they end up with a very large, size of monthly bill. So we detailed down almost, 5 different examples of such cloud cost accidents, and we talked about how you can prevent those kind of accidents in your cloud cost within your organization. So if you have missed that webinar, here is your chance. You can, scan the QR, subscribe to our channel so that you can look at it at a later point of time. If you miss to scan it, we are going to show this QR one more time at the end. So worry not. So before I walk you through the agenda, a few housekeeping rules. We have kept all of you, your video and audio muted for the, throughout the duration of the webinar. At the end of the webinar, during the QA session, we will try to unmute you in case if you want to ask your questions directly. Otherwise, the QA section will always be open. So if you have any question during the webinar content while we walk you through the content, if you have any questions at any point of time, feel free to share it within QA section. At end of each of the section, we will take a brief pause and we will take up any questions which you have. And at the end, we will keep sufficient time for QA as well. We are planning to wrap the entire webinar today in an hour or so. So we will try to wrap the content in 30 to 40 minutes, and rest of the 20 minutes, we will keep good amount of time in case if you have any questions. One other thing, during the course of the webinar, we will take a lot of examples, which is from AWS. Since most of you are already using AWS and it is widely popular, cloud platform. So we have taken examples from them, but the concepts and the ideas and the facts which we share within the, during the webinar is exactly the same across all the cloud platform, regardless whether you are using Azure or GCP, the concepts will exactly be the same. In case if you have any specific question regarding the cloud platform you are using, so Azure or GCP or something else, feel free to ask us a question and we will try to answer to our best. So let's start with the webinar agenda today. We are first going to talk about how cloud pricing model works. This is something you all might already be knowing. We will just do a quick brush of the, the origination of all the problems, right? The entire cloud cost problem comes because of the pricing model cloud platforms have. And we are going to talk about what we mean by the hidden cost of cloud, right? What is exactly hidden inside it. Then we are going to talk about 5 such examples of what are the things which is happening here, or let's say, what are the ways you might be charged in your cloud bill, which are not directly apparent from the cloud pricing model. Then we are also going to talk a little bit about how you can yourself spot these kind of hidden cost in your cloud bill, and eventually we will open the floor for the QA. So let's start with it. How cloud pricing model works, right? So mostly all the cloud platforms, so be it AWS, Azure, GCP, there are other popular cloud platforms as well. Most of them follows a pricing model which is consumption based, or also known as pay as you go. What it means is that you only pay for the provisioned capacity, not you you do not need to plan for a, let's say, very large capacity and pay it upfront. Rather than you can pay it only when you provision it. So if we compare it with our previous days of on-premise infrastructure, where we used to deploy big server racks and all, planning the entire year's capacity, and we used to upfront pay for those server racks, and then regardless whether we are using it or not, we have to keep paying or operating that infrastructure. Compared to that, what cloud has given us the flexibility is that our cost also grows with our need, right? So today I need only, let's say, I'm spending $100 of, cloud spend today. As my requirement grows, my cost can also keeps growing accordingly. So that is what we mean by consumption based. Now, when we look at the consumption-based pricing, there are generally two different dimensions how cloud platforms, charge you. One is purely time-based. Typical example is that a particular, let's say, M5 large EC2 instance will cost you around $70 to $80 per month. So that is on the time-based, right? So the more time you use, more money you pay. The other model is a time plus volume based, right? So a typical example is an S3 or any kind of storage, storage services. So S3, 1 TB of storage. If you use it for an entire month, then you are going to pay for around $23. So it is on time access and the volume access. Now let's briefly touch upon what is exactly hidden cost, right? What we have seen is that a lot of engineering teams, when they are planning for their cloud cost, or let's say they are doing the estimation or during their architecture design, when they do the estimation for their cost, they primarily do it on the provision, infrastructure to be provisioned, right? Which means is that their compute capacity and the storage capacity, that is something they plan for. However, the kind of cost we are going to talk about today does not conform to these two things, right? They are not compute cost, they are not storage cost, they are the other kind of cost which cloud platform charges you. And typically this depends on multiple factors, like, as your usage keeps growing, then these kind of cost will also keep growing. There are other kind of design decisions which can also impact these kind of cost. So that's why we call them hidden cost, because apparently when you are, estimating your infrastructure cost, they might not be so relevant or so clear to you. But as you keep provisioning or as you keep using your cloud platform, then these kind of cost coming, starts coming inside your bill. So that is one part of it. The other part is that the way cloud bills are basically designed, they are, we generally say it, they are designed to be complex or vague, right? So sometimes when you look at your cloud cost, it is hard to spot these kind of cost, right? So when you are looking at, let's say, a AWS bill, you see that, hey, I'm paying this much of cost for my EC2 services, right? But how much of that cost is coming from the pure storage or compute compared to how much of the cost is coming from other kind of, let's say, cost head? These kind of breakdowns are not very clear, within the cloud bill. So that's why we call them the hidden cost, which hides inside your entire cloud bill. And they basically, pops up when end of the month when you need to pay the bill, right? So these are the things we are going to talk about. So let's start with this, these examples. We are going to take 5 examples today. This is, of course, not an exhaustive list. There are, different other, cost heads which can also come in your bill. But we have picked up the 5 most common, hidden costs that we have come across while doing cost optimization for over 50 different startups and growing businesses in our last 1.5 years journey. So let's start with the first one, data transfer cost, right? The elephant in the room. A lot of people gets bombarded by data transfer cost. We have seen customer where data transfer cost is as high as 30 to 40% of their cloud bill, right? Typically, it often remains to be the third biggest line item, or let's say, the third biggest chunk of your entire cloud bill. So that's a huge amount, right? We need to talk about what it is, how do you get charged as per the data transfer cost, and the nitty-gritties of this thing. So we are going to come to that. The first thing, the way cloud prices has been designed from data transfer point of view, Cloud allows you to get in for free, but getting out is not free. What it means is that whenever you are taking any data within your cloud platform from outside, it is always free. But whenever you want to get out, so you want to take the data out of your cloud platform, it is unfortunately not free. So this is where typically cloud platforms will lock you down. So if you have, let's say, gathered a huge amount of data within your cloud platform, let's say few terabytes or few petabytes of data, it becomes very hard to take that data outside. So typically these kind of scenarios will come in when you are doing a cloud migration, or maybe you want to leave the cloud, or let's do go back to your on-premise. It becomes very costly affair or very hard to move that data outside. There are certain ways how to minimize that cost, but that is not focus of our webinar today. So we will keep that separate. Today, we are going to talk about while operating within the cloud platform, how you are going to get billed for your data transfer cost. So here is a small diagram we are going to take, and we are going to explain about how generally data transfer cost is distributed. So what you see over here is typically how AWS infrastructure looks like. The green box you see is the entire AWS global infrastructure, right? So there are multiple regions across. There are almost 40 different regions across the entire world. Similar kind of different regions you will get in Azure and GCP as well. So this is the global network or AWS network. Within that, there are multiple regions. So Mumbai is a region, Hyderabad is a region, Virginia is a region, Oregon is a region. So these are the different regions AWS provide. And within those regions, you will typically find 3 to 4, availability zones. So typically a single availability zone is a data center. So for example, within Mumbai, there are multiple data centers of AWS. These are physical data centers where you can imagine a building. Within that, there are multiple server racks sitting in. So availability zone will typically be a data center. A region will be a cluster of data center, which is the cluster of multiple availability zone. And then the global network is basically consisting of multiple regions, which are generally connected through the internal AWS network, which is GBPS scale network connected through the submarine cables, and the global how internet is distributed. Now let's talk about how the data moves into this entire infrastructure and how you are going to get built, right? So I am assuming your my mouse pointer is visible so that I can quickly walk you through. So internet is everything outside your AWS network, right? So outside the AWS network, wherever you are connecting, that is our public internet. Anything you move from the internet within your AWS infrastructure, right? So let's assume that within your AWS infrastructure, you are downloading something from outside. Maybe, let's take an example. You are downloading a few photos. Your application is basically a, let's say, photo album software. It downloads photos from, let's say, Google Drive or something. So now the data is basically moving from outside, which was in internet, into your AWS infrastructure. Anything which moves inside, which is marked as number 5 here, it is called ingress traffic, which is going from outside to inside, and it is always free. Anything you are taking from outside to inside will always free. Now let's go from the beginning. We talked about different availability zones, right? One availability zone, which is typically a single data center. Anything moves within that single availability zone is always free. So if you have deployed multiple EC2 instances, or maybe multiple virtual machines, I'll use a little bit of generic term, multiple virtual machines, multiple databases, maybe some serverless functions. As long as you deploy everything within a single availability zone, all the data transfer within your infrastructure is always free. There is no charge associated with that. But as soon as you distribute your infrastructure across multiple availability zone, right? So now I distribute, my infrastructure within the Mumbai region. I distribute it to AZ1 and AZ2. Anything which travels between an inter AZ data transfer, you will be billed for that. Part one. So within anything, two different availability zone, you are going to bill for that. Then if you move from one region to another region, again, you are going to be billed for that. So that's the inter-region traffic. So we talked about number 2 and number 3. Eventually, anything which moves from your cloud infrastructure to outside. So for example, let's say you have deployed, let's say, data analytics platform, and your customer is opening their browser and downloading some data from your platform. So basically, this is going from within your AWS infrastructure to outside network. So you are going to, so this is called egress traffic, and you are going to pay for your egress traffic, right? So I am going to summarize the entire thing. Anything goes inside is always free. Anything within a single availability zone is always free. But within availability zone traffic, within region traffic, and from cloud platform to outside, which is called egress traffic, these three things will be charged from your side. Now let's take a step back and try to understand what is happening here. If your entire infrastructure is sitting idle, it is not talking to each other, you do not pay for data transfer charges, right? In the initial days, when you are, let's say, building your software or deploying your SaaS solution, there are very less number of users talking to your infrastructure. So there are very less amount of data being transferred between. So you will get a, let's say, very minimal charges. Sometimes it is close to zero. So effectively in your cloud bill, you will not see them. So you will see that there are probably a few line items. Sometimes if you look at your cloud bill, there are hundreds of line items, and essentially we do not, go through them, all of them. And eventually your data transfer charge in the beginning will be zero. But as you keep using the infrastructure, as more and more users log into your infrastructure, more and more data will be transferred across AZs, across regions, eventually outside, and your data transfer cost keeps increasing. So this is how you are, going to get more and more data transfer cost. You will be paying for more and more data transfer cost as you move from point A to point B. So from your, as a startup, when you are moving from 0 to 1 journey, probably your data transfer cost will be very low. But as you keep moving from 0 to 1 to 10 or 10 to 100, your data transfer cost will keep increasing. Now let's take a moment and try to understand what are the options we have to reduce your data transfer cost. Reducing data transfer cost is a purely contextual topic. What we typically suggest is that when you are designing your architecture, you need to understand and analyze all the points between which your data moves, right? So for example, let's say you have two different EC2 instances across two regions, which is talking to each other, right? Now you need to understand what kind of data is being transferred between these two and how you can minimize the footprint of that data, right? So typically how it is done is that if you are transferring data, it is always suggested that you do as much processing as possible within the single availability zone. Then you move the process data, right? Because process data is generally smaller than the raw data. But it is still a lot of contextual how you design your architecture. But what I would suggest all of you is that whenever you are designing your application architecture, always think about the points between which your data moves and think about how you can reduce the size of that data so that you are not getting bombarded by the data transfer cost. One last thing on this topic, data transfer cost is also dependent on the services. So the kind of data transfer cost you will incur between traffic between two EC2 instances and two NAT gateways or different AWS services are little bit different. So they go up and down. So it is not a flat charge. So always refer to your cloud documentation to understand what kind of data transfer cost you will be charged. So I'll take a brief pause here. In case if you have any question, you can drop it. Otherwise, we can start in the move to the next topic. Okay, so let's take up the next item, which is the backup storage cost. Now, this is another another sort of interesting topic, and it is again highly tied up to the architectural choices, or let's say the kind of deployment configuration you do, and this cost can also bombard depending upon that. Now, let's first understand what is backup storage cost, right? Typically, if you are using EC2 instances or RDS databases, then your database can be backed up, your EC2 volumes can be backed up, and you basically take snapshot, right, which is the backup of your database. These backups are also cost you money, some sort of money. Now the challenge, typically what we see, the problem with backup storage cost is that if we take the example of RDS, where mostly the backup storage cost bombard, the challenge is that AWS only charges you when you go beyond your provision capacity. You take an example. So for example, you have deployed a database, and for other cloud platforms, the concepts are similar. So in AWS, let's assume you have deployed a database with 1 terabyte of 1 terabyte of storage provision capacity. Now your actual data, the physical data, is stored only 100 GB. So you have 900 GB of provision capacity empty. Now, till the time your backup consumes all that 900 GB, so basically, backups are free until your provision capacity is finished, you are not going to be charged. And that is the typical reason we see at a lot of customers, is that they do not get to see the backup cost initially during their initial journey. All of a sudden, their backup cost, becomes a very large chunk in their cloud bill. The reason it happens is that data keeps growing, right? In your database size also keeps growing. So your provision capacity also keeps, emptying up. And at some point of time, when your backup basically, goes beyond that provision capacity, then only when you see a line item in your cloud bill. Now, the next challenge, backup, we generally say that storage is cheap, right? So much cheaper than compute. So what is the problem? Even if we are storing a backup, what is the problem? The problem is with the recurrence of that backup. Now, let's take an example, very simple example. You have set a daily, database backup of your, RDS instances and all. So every day you are basically taking a snapshot of your database. Now, going to my same example, you have a, let's say, 1 terabyte of provision capacity, 100 GB of data you have inside your database. Now let's take an example of every day you are taking a snapshot. So your 100 GB becomes a one snapshot, then next day you are taking. Now you are doing it consistently for 90 days. Eventually, what you are storing is 9 terabytes of data, right? So that is what we mentioned, is your backup policies are super important to make sure that you are not getting bombarded by your backup storage cost, right? This problem is typically with database, because in database, it is not a incremental storage. EC2, it is basically an incremental storage, so you do not get your cost does not increase exponentially. But what you need to make sure whenever you are doing backup storages, make sure of two things. One thing is that your backup storage policy is intelligently designed, so you store data for only the time where you need, for the time duration you need. One very common way of let's say avoiding backup cost is that taking a snapshot within S3, right? So for example, if you have a policy, policy to basically store or let's say backup for, I don't know, maybe, 6 months to 1 year, instead of keeping them as a database backup, you should always export it and store it into S3 or any kind of object storage, because object storage are much cheaper than the, volume storage, right? So that is one of the things. The other challenge with backup is that in case if you are deleting the original infrastructure, your backups are not cleaned up automatically. So let's assume you have deployed a database or you have deployed a EC2, you delete that EC2 or the database, your backups are not automatically deleted. So we have also seen cases where people have deleted their original infrastructure, but they missed to delete their backups. So eventually it kept piling up and costing at some point of time, costing 20-30% of their entire cloud bill, because they did not clean up the backups, right? So this is also one more thing. So you need to be very careful about your backup policies, how you are designing, how much data you are keeping, and if you are keeping it for a longer time, where you are keeping, right? You can offload it into a object storage or something. And the second thing is that whenever you are deleting the infrastructure, if you do not need the backup, clean it up. So these are the two things from a backup storage cost. Again, I'm going to take a little bit of pause in case if you have any questions, feel free to ask, or we will move to the next item. And I'll also have get a little bit of water.
There's one question, Atanu.
Yeah.
On data transfer cost, I think on your earlier topic, is transferring one file of 100 MB equal to 100 files of 1 MB?
Yes. So typically, it will be a little bit of different. It is not exactly the same because of the metadata and everything which is being transferred, but largely that is true, because data transfer costs are generally charged as per volume. So per GB of data transfer or per terabytes of data transfer is what you charged for. So eventually it is the same. So if you are sending, let's say 1 MB of 100 files or 100 MB of one file, it's the same. Okay, great. So that was a nice question. So let's move to the next item. Next item is another interesting topic, and it is more interesting, if you are using AWS, public IP cost, right? Uh, Earlier in before I think it was June or July 2024. Before that, what used to happen is that if you are spawning up any infrastructure inside AWS, for example, if you are spawning up an EC2 or some kind of, let's say, ECS clusters, you used to get one associated elastic IP for free. So if I'm spawning up an EC2, I beyond the compute and storage cost, I do not need to pay anything separately for my elastic IP. However, now what AWS, the pricing has been changed, and what they are doing is that every time you are spawning up any infrastructure, if it has an associated public IP, you have to pay for it. And typically one associated public IP costs you around $4. So what happens is that if you are running a whole bunch of EC2s or a whole bunch of ECS clusters where you are running multiple containers, and if you have a public IP associated with it, you are going to pay a good amount of money for that. And it typically ranges good amount of money if you have a lot of EC2 instances or ECS clusters. So this is something you need to be careful about. Couple of strategies you can follow. One thing is that if your design allows you to do, you should move your infrastructure into a private network, right? So instead of assigning public IPs to your EC2s or ECS clusters, you should move the infrastructure into a private network and use a NAT gateway or an internet gateway to basically route the traffic outside instead of directly attaching public IP. So that is one way of reducing the public IP cost. But generally, whenever you are deploying any infrastructure, keep an eye on the public IPs you are assigning. The another aspect of this thing is basically the elastic IPs, right? So if you are aware, generally you are allocated a dedicated static IP for your use. The problem with elastic IP is that you are basically paying for elastic IPs regardless whether it is used or idle, right? So if you have allocated a lot of elastic IPs and you are really not using it, you better release them, because even if you are not, let's say, those are are associated with a particular instance, you still keep paying for it. So even though the charge is very much less, it's only $4 a month. But if you are running hundreds of EC2s and ECS clusters, this is one area where you can save a little bit of money. I'll move to the next one, pretty interesting one, which is the API calls. Now, so far we have all been discussing about three things, right? So we pay for the provisioned capacity, which is typically the storage cost and the compute cost. Then we talked about data transfer cost. Backup cost was eventually a storage cost. Now we got to know that there is also a way you can be charged to access your data. So you are not storing it, you are not doing any kind of computation, but just to access your data, you can also be charged. So that is also, one caveat of the cloud pricing model. So a few examples we are going to take: S3, DynamoDB, CloudWatch, the secret managers and KMS within AWS. For other clouds also, there are similar services where you basically get charged. These kind of charges are done based on how frequently you access the data. So if I take an example of S3 buckets, so every time you put the data within your S3 bucket, every time you read the data from your S3 bucket, you are being charged a certain amount of money. So this is not about the storage. It is separate to access that particular data. This typically can go go a really higher amount if your application is really chatty. So for example, let's say within your object storage, you are storing a huge amount of let's say small files, maybe some kind of images or some binary files you are storing in a huge amount, and you are also accessing them very frequently. Then these kind of API call charges can go really higher. We have seen let's say cases where people end up spending thousands of dollars eventually on just on S3 API calls. So you need to be very careful about. So to prevent this particular cost, What you need to make sure, again, whenever you are accessing any kind of object storage or any kind of services within your cloud platform, which costs you per API call, you need to make sure that you are minimizing the number of times you access that particular data, right? So for example, in your S3, typically you can read it once and you can cache it within your application side rather than reading it multiple times, if you can do so. So these kind of architectural tweaks can help you basically reduce the money you spend on API calls. So I'll finish the 5 examples with the most obvious and the most boring one at the very end, which is the tax, right? Typically what happens is that within AWS, all the pricing model, all the pricing data we get to see are basically exclusive of tax. So for example, let's say in the beginning, we saw that, hey, our M5X large, instance across the entire month costs you $72, right? This is the AWS pricing. But let's assume you are running only that single EC2 machine in your account. What is you are going to pay at the end of the month? You are actually going to pay $80. Why? Because another $7 you will be charged for tax. Unfortunately, this is the reality of our current world. You are always being taxed, and AWS also charges you a tax, which is not inclusive in your pricing. So whenever you are estimating for any kind of, let's say, cloud pricing within your organization, always factor in the amount of tax you are going to pay. Now I'm going to talk about typically how tax work within AWS. It depends on the on the country your AWS account is registered in. Typically, like, I'm assuming most of us are based in India, so our AWS account will be registered with the AIPSL, which is the Amazon India Private Limited. Amazon India Services India Private Limited, I think that's the name. It's so in India they are charging 18% of GST. If you move to other countries, for example, if you move to EU, in UK it is 20% of VAT they charge. In other European countries it varies between 17 to 20%. In US there are different tax slabs for each of the states. So typically what will happen is that eventually, based on the tax slab you are in the country you are registered in, you will be paying flat extra for your tax. So if you are in India registered entity, you are going to pay extra 18% on the entire money you basically spend on your cloud. So always factor in this money whenever you are planning for your entire cloud infrastructure. And if you are looking at your cloud bill, this tax will always come in as an extra line item, but they do not provide a breakdown. So you might see a single line item. There are no, let's say, no clarification about what it is, but it will be basically the tax amount in your cloud bill. So with that, I have finished all the 5 things we wanted to talk about. If you have any questions or any experiences in your organization, how you have seen these things happening, or any specific examples of hidden cost which you got surprised about, feel free to share, drop a note, and we will unmute you. With that, I'll briefly talk about how you can basically spot these kind of hidden cost in your cloud bill, right? The first and foremost thing what we always suggest all our customers is that do a regular review of your cloud bill. If you are doing it only once a month, or maybe let's say a couple of times a month, there are higher chances that if you are getting bombarded by one of these hidden costs or any kind of anomalies in your overall cloud bill, there are higher chances that you are going to end up spending higher money, or let's say larger money. So we always suggest that you should at least do a cloud bill review every week. It would be best if you can do it every day. Maybe make it a every morning, let's say every morning, some kind of rituals as part of your stand up or something. It's the best thing you can do. The second thing you can do is that to identify hidden cost, if you just look at your cloud bill at the service level or the region level, it is very hard to identify what kind of let's say line items you are basically getting billed for. So always switch to your usage level breakdown and then try to dig into your line items, right? So if you typically look into the usage level breakdown, you will see maybe a few hundreds, or for a larger organization you might see few thousand lines of entries. So hard to go through all of them. So what the typically strategy you can take is that sort your bill by the largest line item, and you can work backward from there. So go through each of the line item which is costing you money. There are very good documentation for all the cloud platforms regarding how they charge you. So if there is a line item within your cloud bill, you can simply go to the documentation and search for what it means. It will give you the clarification of why you are being charged that particular money, and you can keep working backwards and identifying any kind of line item where you are being billed but you did not expect it to be. That's how you are going to identify your hidden cost in your cloud bill. I With that, I think I am done with my content. I was also able to wrap it within 40 minutes. I was able to meet my promise. So before we move to QA section, if you have any questions, feel free to raise it in the QA section or raise your hand. Uh, One more time, in case you missed our webinar, now with the content we just covered, there are more insights, there are more tips and tricks we shared in our earlier webinar. So please feel free to scan this QR, subscribe to our channel. We are also going to upload this current webinar in our YouTube channel. So in case you missed some part, you want to go back and understand that part one more time, it will be live in YouTube in by end of this week. So please scan and subscribe to our channel. All our future webinars will also be live into our YouTube channel. Before we open our open the floor for the QA, one thing I wanted to quickly highlight about what we do as Clofio. So we are in Clofio, our mission is to basically help startups identify, analyze, find gaps in their cloud cost, how they can save money, and we help them basically execute that kind of thing. So it's a specifically specialized service designed for startups and growing businesses called cost optimization as a service, where we take a look at your entire cloud bill, the kind of insights we just talk about. We bring in this entire sleuth of experience on your cloud bill, identify how you can optimize, and typically we are able to save approximately 30 to 40% of your cloud bill. So if you are interested, feel free to drop us a note. I will share the coordinates at the very end. Okay, so that's the end of our today's webinar. Here is the floor open for QA. You can also scan this QR to follow us on LinkedIn. We keep publishing all the updates, future webinars in our LinkedIn channel. So please feel free to scan and follow us.